Rounding and estimating. The steps for rounding are as follows. Identify the digit in the place value being rounded. Look at the digit to the right of the place value being rounded. If the digit to the right is less than 5, then leave the digit in the place value being rounded the same and change all of the digits to the right of it and before the decimal place to zeros. And if the digit to the right is greater than or equal to 5, increase the place value being rounded by 1 and change all of the digits to the right of it and before the decimal place to 0. So when rounding to a place value after the decimal place, the trailing zeros are not usually written after the location you are rounding to. So that's important to realize as well. So let's go over some examples to really see how this works in real life. So for the examples, we're going to round to the indicated place value. So first of all, we want to identify what number is in the 10,000 place value. So that is our 2 in this case. And so we need to now look at the number to the right of that. So that is our 7. Because our 7 is larger than 5, then we have to bump up our 2 to a 3. So it becomes 3, and then we put zeros in all of the places after that number. So it becomes 30,000. Now let's take a look at the next number. So it's the same number, but we are now rounding to the thousands place. So I need to identify the digit in the thousands place. And because my number to the right of that is a 3 and it's less than 5, then I keep it the same. So it becomes 2, 7, and then everything else becomes zeros. So then this number, so 27,356 rounded to the nearest thousand would be 27,000. Now we're going to take a look at what this number would be rounded to the nearest hundred. So I identify the digit that's in the 100 place value, so that's my 3. And then I look at the number to the right of that. This number is a 5, so I have to round my number up. So instead of writing a 3, I'm going to write a 4 in its place, and everything else becomes zeros. Now let's see what happens to a new number. So this is 56,429 and 253 thousandths. So now I want to round this to the nearest hundredth. So my 5, the second 5, is in our hundredths place. So we always look to the number to the right of that. And so that is a 3. 3 is less than 5, so I keep my 5 the same. So this becomes 56,429 and 25 hundredths. I don't need to include my 0 after the 5, but if you put that in there, I wouldn't mark it wrong. So notice that I had to put my zeros when they were referring to whole numbers or numbers to the right of the decimal place, but after that, I don't have to do that. Or sorry, to the left of the decimal place. My apologies. All right, so now let's take a look at the next example. So I have 392,653 and 452 tens, or sorry, thousands again. My apologies. So what you need to do is you need to identify what digit is in the 10th spot. So that's my 4. And I always look to the right. To the right of that is a 5, so anything 5 or greater tells me that I need to bump that number up that I'm rounding to the next number. So this will be 392,653 and 5 tenths. because I'm rounding up. And the last one is our whole number. So when we're looking at a whole number, that's the same as the ones. So we're looking at rounding to the ones position. So that's what that refers to. So always look to the number on the right. So that's a 2, which is less than 5. So I'm going to keep my 9 the same. So this will be 8,539. And that is how we round the indicated place value when we are looking at either numbers that are whole numbers or to the left of our whole decimal place, and numbers that are decimal numbers, which are to the right of the decimal place. So we can take that idea of rounding to do some estimations as well. And we can do this because sometimes dealing with numbers in our head, so that mental math, can be challenging if we don't think about rounding. So numbers can be rounded to make it easier to do calculations mentally, so answers can be estimated with relative ease. And this allows us to determine whether or not our answer would make sense or not. If we can identify what the answer could be, then when we are doing our calculations, if we get a number that is really far away from our estimation, then we know we've made some sort of calculation error. So this is a way to sort of check that. So let's take a look at doing this sum. So we want to round each number in our 3 numbers here to the indicated place value, and we're going to determine an estimation of that answer. So instead of actually adding up all of these digits, we're going to estimate first, or round first, and then estimate. So the first time we're going to do this is we're going to round it to the nearest tens. So that is looking at the 7 in our first number, our 4 in the second, and our 3 in the first. So in this number, because the number to the right of that is a 6, I have to round this up to a 4. In the second number, because the number to the right is a 2, I keep that the same. And in the last number, because the number to the right is a 5, I have to round that 7 up to an 8. So this becomes 2,740 plus 3,640 plus 680. So I made sure that I rounded up the first and the last number. So now I'm going to add these up together. So 0, 0, 0, 0. 4 and 4 is 8, plus 8 is 16. I write my 6, I carry the 1. 7 plus 6 is 13, plus 6 is 19, plus 1 is 20. So I am writing my 0 and carrying my 2, and 2 and 2 is 4, plus 3 is 7. So that would be my estimation if I round these to the nearest 10. Now what happens if I round this to the nearest hundreds? So in my first number, that's my 7. My second, that's my 6. And in my last one, it's also my 6. So for my first one, I look to the right, it's a 3, so I keep it a 7. In the second number, the one to the right is a 4, so I keep that as a 6. And in the last number, the number to the right is a 7, so I have to round this 6 up to a 7. So my numbers will be 2,700, 3,600, and 700. So those are the numbers I'm now going to add together. Zeros, 0, and now we can look at some numbers. 7 plus 6 is 13, and 13 plus 7 is 20. So I write my 0, carry my 2. And 2 plus 2 is 4, plus 3 is 7. So that rounds to 7,000. And then the last one, we are going to round to the thousands. So I'm going to take a look at my 2 in the first one, my 3 in the second one, and this place value, which is just above my 6 in the second one, or in the last one. So for my 2, I look to the right. That's a 7 because it's larger than 5. I have to round that 2 up to a 3. So this becomes 3,000. For my 3, I look to the right. That's a 6. It's greater than 5, so I have to round that up to 4,000. And for my last number, I have no digit here, but I'm going to look to the right, and that's so right now this is a 0. So I look to the right, and it's a 6, which is greater than 5, so I have to round that up to a 1. So this will become 1,000. So again, I'm going to add these two together, or all three together. I have all of my zeros first. 3 plus 4 is 7, plus 1 is 8, so that estimates to 8,000. So which one of these was easier to calculate mentally? Our last one, rounded to the thousands position, was the easiest to calculate mentally because we only had one column of numbers to add together. All the rest of those were zeros. So that should give you an idea of making sure that when we are estimating, always try to round to the largest place value possible, and that way that mental math is a lot easier to calculate. So when rounding values, the answers are not always exact. So we need to use a symbol that is a equal sign with a little dot above that. Sometimes that can also be shown as a squiggly equal sign as well. And that's used instead of an equal sign because an equal signifies an exact answer, where the symbol with the equal sign with the dot shows that it's been rounded. So it's an approximation. So the answer is approximately equal to whatever it's being given to us. So it's not an exact answer, it's an approximation. So when we are asking to estimate, we always have to remember when we are writing our solution to include that symbol. So I'm going to estimate the answers by rounding each number to the greatest place value first. So I'm going to take a look at my 10,000 place for my first number. The number beside that is an 8, so I'm going to round this one up to a 6. So I have 60,000. My second number in my 10, also 10,000, the number to the right of that is a 1, less than 5, so I keep that as a 2. So it's 20,000, and I'm subtracting these two. I can write my zeros, and 6 take away 4 is 40,000, so it's approximately 40,000. For my next one, I want to round my numbers to the greatest place value. So in this case, it is the thousands position in my first number. The number to the right is an 8, so I have to round that up to a 4. So I can either line it up as I did here, or I can write it vertically. So I can write 4,000 plus, and I also want to round to the nearest thousands for my second number. To the right of that is a 2, which is less than 5, so I keep it as a 1, so that is 1,000. And I'm taking away, I'm rounding also to the nearest thousands. The number to the right of that is an 8, so it's larger than 5, so I'm rounding this up to a 3, so 3,000. So 4,000 plus 1,000 is 5,000. And 5,000 take away 3,000 is 2,000. So the answer is approximately 2,000. And sometimes when we are rounding, we're not going to be able to round them both to the same place value. So in this last one, I can round the first number to the nearest hundredth. So the number to the right of that is less than 5, so I keep it as 100. And for this one, I'm going to round to the nearest 10. So I'm not rounding to the same place value, but I'm rounding to the greatest place value for each of those numbers. So the number to the right of that is larger than 5, so I'm rounding that up to 30. 100 times 30 is 3,000. So that's 1 times 3 and then 3 zeros. So also I want to make sure that I include that dot above my equal sign because this is an approximation, it's not the actual answer. If you have any questions about today's lesson, please reach out to me via email or sign up for a virtual help session, and I will see you in the next lesson.